Okay, Geometry, Chapter 2, Section 2, Inductive and Deductive Reasoning. The basis of all of this will be a statement, will be a conjecture. And that conjecture is an unproven statement which is based on observations. So you might be looking at something and be able to tell what it does 3 or 4 spaces down the road. For example, if I had, let's take a little square here, and I'm going to make a bunch of those, so give me just a second. There's probably an easier way to do this, but hey, let's just have some fun with making shapes. So let's say that I have 1, and then I have 2. Nope, I don't want to do that. And then I have, let's see if I can get this one. There we go. And then I have 3. I'm going to go ahead and get rid of this one. That was one too many. So my conjecture would be something to the effect that I add a box at each position. So if I got over to the 8th position, I could make a statement that at the 8th position, there would be 8 total boxes. And again, you will see different kinds of drawings with these. Now, it is possible that I could make a conjecture and then I could be able to prove it wrong. And if that is the case, then that is called a counterexample. And so let's say I have the conjecture, the sum of 2 numbers is always more than the greatest number. Okay, the sum of 2 numbers is always, keyword there is always, greater than the greatest number. Now, this looks like a pretty true statement. You might have some numbers popping around in your head. Let's say we take 2 plus 6. The sum is greater than the greatest number. I think you would agree. How about 12 plus 10? The sum is greater than the greatest number. However, watch this. It would be awesome if I could write it. How about negative 5 plus 2? Those are both numbers. Negative 5 plus 2 is negative 3. So the sum of that one is not greater than the greatest number. Negative 3 is not greater than 2. And so that is called a counterexample, when you can prove something wrong. So each one is possible to prove it true, but there might be something that makes it false. And again, that will be your counterexample. So let's talk about a couple of laws that hold truth in this reasoning. We're going to look at the law of detachment first. Okay, and so let's say I have segment, let's just say AB is equal to CD. The law of detachment says that if AB is equal to CD, then segment AB, again I'm just making it a little bit different, is congruent to segment CD. Again, took the initial values AB equal to CD and then just changed them into segments and made them congruent. Didn't change the statement. They're still equal to each other. Congruent is just another name for equals. Now, we also have the law of syllogism. And the law of syllogism has to do with looking at three different statements. So if I had x squared is greater than 25, or then x squared is greater than 20, and x is greater than 5, then x squared is greater than 25. Notice that I have x squared greater than 25 in both of these, which means I can rewrite this because I should have written if then statements. If x squared is greater than 25, then x squared is greater than 20. And then if x is greater than 5, then x squared is greater than 25. Since those are the same, that means I can now compare these two in a third statement. If one is a conditional to the other, and then something new is a conditional to the same one, then I'm going to go down to this next one, and I'm going to write in black, then I keep saying it, but I'm not writing it, then x greater than 5. No, I'm saying that wrong. I want to get this right, guys. Then I can change my statement to if x is greater than 5, then x squared is greater than 20. Excuse me. All right, so I'm comparing the exact same thing. So then I just combine those two in a third statement. So law of syllogism will take two statements and create a third statement out of it. And that is Chapter 2, Section 2, Inductive and Deductive Reasoning.